So for this question, we're going to solve for what's called the Lagrangian point between the Earth and Moon. So whenever you have two massive bodies, there are different locations around those objects where the forces are going to balance out. And this is the simplest Lagrangian point, the point that there's a single point along the same line that connects the two objects. But if you're interested, you can look it up, and there's always 5 different Lagrangian points when you have two massive bodies. So for example, we have the Sun and the Earth. There's actually 5 of the Lagrangian points. We have what's called L1, L2. There's a Lagrangian point over here, L3, and there's L4 and L5. Now mathematically, you may say, like, how do these other ones work? Like this one's pretty straightforward. This one we're solving for. The Moon is pulling one way, the Earth is pulling the other way. The other ones work out because of the fact that the whole thing's moving, the whole thing's circling around, like the Earth is circling around the Sun. So the forces are balancing out in such a way that it includes the circular motion. So the centripetal force involved. It's a little bit too complicated for what we're doing right now, so we're just going to focus on this what we call the L1 point. So lots of cool videos online if you're interested in looking those up. For now, let's just look at how we can solve for the L1 point between two large bodies in space. So this one, we're looking for, when does the force of gravity of the Earth equal to the force of gravity of the Moon? So I'm just going to say that Fg of the Earth is equal to the force of gravity of the Moon. So you end up with this equation again. So Gm of the Earth times some m. So that's, in this case, the little m represents that object that is between the Earth and Moon, over some r1 squared. So I'm going to say this is some r1, and this is some r2. So we get Gm of the Moon times the mass of the object between them, divided by r2 squared. Now right now there's too many variables, so we have to somehow relate the two of them together. So this one, we have the radius from the Earth to the Moon is 3.84 times 10 to the 8 meters. So what I can do is I can define, say, this distance, the Earth to the object, as a distance x. So if the Earth to the object is x, then the object to the Moon would be 3.84 times 10 to the 8 meters minus x. So now we're going to end up with a single equation with only a single variable. So we get G mass of the Earth. Now the little m's cancel out, we can ignore those, divided by x squared. Actually, we can cancel out capital G as well. So we get mass of the Earth divided by x squared is equal to the mass of the Moon divided by 3.84 times 10 to the 8 meters minus x. We're going to have to square that whole thing. So we have to use it to expand. We'll have to eventually expand those brackets. So I'm going to cross multiply this to simplify our expression. We get 3.84 times 10 to the 8 meters minus x, all squared, times mass of the Earth is equal to x squared times mass of the Moon. Now we could expand the brackets, group like terms, we'll end up with the quadratic, but what we can actually do is I'm just going to go ahead and just square root both sides. This is rearrange this one more step before I square root. So I'm going to have 3.84 times 10 to the 8 meters minus x, all squared. I'm going to divide both sides by the mass of the Earth before I square root both sides. So x squared over mass of Moon over mass of Earth. Okay, so we're going to go ahead and square root both sides. We square root the left side, we square root the right side, and we end up with 3.84 times 10 to the 8 meters minus x. And that's just equal to the x times the square root of the mass of the Moon minus mass of the Earth. Now it's just a matter of grouping like terms, because even though we have square root of mass of the moon over the mass of the Earth, that's just a number. I'm going to solve it algebraically though. So we have 3.84 times 10 to the 8 meters. I'm going to move the x term over, so we get x plus x times the square root of the mass of the moon over the mass of the Earth. I'm going to factor now. Get 1 plus the square root of mass of the moon over mass of the Earth. So we can see that x is simply just 3 points, the distance between the two objects, so 3.84 times 10 to the 8 meters, divided by 1 plus the square root of the division of the two masses. So we do 1 plus square root of mass of the moon over mass of the Earth, plug it all in, and we end up with the value of x is equal to 3.46 times 10 to the power of 8 meters. So this equation can actually be used for any of the Lagrangian point. Just need to know the distance between the two objects plus the masses of each object.